Student, today we are going to see how to take the refractive index of glass slab using travel microscope. These are the concept we are going to learn. Okay. So, refractive index of the glass slab is 1.5, no unit. Okay. Refractive index is equal to when the light is traveling from air to glass, real depth by apparent depth. The value we are going to get as the 1.5, approximately it is a no unit. This only we are going to learn, we are going to find using of travel microscope. So, first we are going to learn how to handle the travel microscope. We have two scale, one is a vertical scale, another one is a vertical scale, another one is a horizontal scale. We are going to use vertical scale. So, this is vertical scale. Okay. So, now initially I am going to focus this one using of this microscope. Okay. You can adjust this to focus. Initially if you adjust, don't touch this one to initially if you got this clear image means don't use this to adjust, use this one to adjust up and down. Only vertical reading we are going to use. Okay. Yeah, now initially I am going to focus this one using of microscope. Yeah, now it is focused using of microscope. Okay, I use this handle to adjust the microscope. Okay, after we set this, only we have to use up and down. Okay, here see we have two scale, one is the main scale, another one is a vernier scale. Okay, this is main scale, this is a vernier scale. Once you focused, only use up and down to focus the image. If you disturbed, if you are using this to adjust means your total reading is going to become spoiled. Okay, only use this one to adjust. Okay, that is an important point you should follow. Okay, the next thing I am going to tell you how the scale is given. Okay, so it is a normal scale. If example, so it is a vernier scale. Okay, this one we will take it as a vernier scale. This is a vernier scale 0. Okay, so this reading only I am going to show how to take it. Okay, so this is a main scale. In case it is a 5 centimeter. Okay, it is 5.1. Next one 5.2, next it is a normal scale only 5.3, 5.4, then 5 will be bigger, then 5.6, 5.7, 5.8, 5.9, 6 centimeter. It is a normal scale only. Okay. In case our 0 is here, your main scale reading is 5.3. Okay, your main scale reading is 5.3 because your vernier scale 0, this was 0. Okay, right now it is coinciding 8.1 centimeter. Okay, I am doing actual thing, it is 8. Okay, it is 8.1 and it is 8.2. Our scale in between here. Okay, so our main scale reading is 8.1. So 8.1. Okay, one more thing I want to represent. Okay, so in between small line is there. So it is 8.3, it is 8.4. The small line, it's going to be 8.05, it's going to be 8.15, it's going to be 8.25, it's going to be 8.35. So it is half of mm is getting increased. Okay, so now it is 8, so it is 8.1 and it is 8.05. The next small line, then bigger line, it's going to be 8.2. Okay, our reading is here. So what is the main scale reading? 8.1 and also it's crossed 8.15. Our main scale reading is 8.15. In case your 0 is here means your main scale reading is 8.1, not 8.15. Okay, if you cross this line, it's going to be 8.15. If it's not crossed, it's going to be 8.1. Now our reading is crossed 8.15. So the main scale reading is 8.15. Next is vernier scale reading. Before going to the vernier scale reading, just I am going to show you how to take the least count. Okay, our least count, it is going to be half mm. This is going to be half mm. This difference is half mm. So half mm is divided 50 division. So half mm is divided 50 division. So half mm is divided 50 division. So how many mm is divided with? 1 mm is divided with 100 division. 1 mm is divided with 100 division. So 1 mm is divided with 100 division. 1 millimeter is equal to 100 division. So 1 divided by 100 is called least count. So least count is 1 divided by 100. It's 0.01 millimeter. We can call it is our least count. Okay. Now how many centimeter? Because here this one we are taken in centimeter. Okay, so how many centimeter? No, it is 0.01 0.001 centimeter. Okay, our least count is 0.001 centimeter. Okay, now we will see what is a vernier scale reading. Okay, here we have vernier scale, here we have main scale. Okay, so vernier scale have 50 division. Main scale have already I said it's a normal ruler only 1, 2, 3, 4, 5, 6 centimeter. Okay, so where the vernier scale and main scale is coincident, no, that is the point of vernier scale reading. In case it is we have 50 division. Already I said it's divided 50 division. Okay, it is 22nd line is going to be coincident, means vernier scale is 22nd. Okay, so you can observe where this and this scale, where this two scale is coincidenting, that is called vernier scale division. So where it's going coincidenting means 22 I am taken. Okay, our vernier scale coincident will be 22 division. So now total reading. So what is a total reading? Okay, so initially I focused this one, this pen mark to in a microscope. Okay, so I got the total reading is 8.172, because with this least count is 0.022, because our least count is, we know already, 0.001 centimeter. Okay, finally we got this as the answer. So when we are adding main scale and vernier scale, finally we will get 8.172 as the main scale reading. It is going to be the centimeter. Okay, now I am going to show you how to take the reading. Now we got 8.172 centimeter. Okay, we focus this pen mark. Okay, then I placed glass slab. Okay, then I am vertically I increase the height. Okay, so before we learned without glass slab, now I placed as a glass slab, the point is going to be increased. Again I am focusing this going to be the shift. Okay, then I am taken it is without glass slab, then I am going to measure with the glass slab. Okay, the refraction through the glass slab. Okay, with glass slab. Okay, with the glass slab also you can take it what is main scale reading and what is vernier scale reading and what is total reading. Okay, in case it is going to increase with 1 mm or 2 mm, so I am going to observe how much is increased. Okay, so with the glass slab also we can take the reading, some of the reading. Yeah, actually I have another reading to show that to prove refractive index is the 1.5. Okay, so we have it is the first without glass slab they got 4.65 and vernier scale coincident is a 32, they got this value which is going to be without glass slab. Then they got with the glass slab is the 5.1 and vernier scale coincident is a 36. Okay, so for initially they got without glass slab 4682. Okay, main scale reading is 4.65 and vernier scale coincident is 32. Okay, the total reading will be this much. Okay, then with the glass slab they got is the 5.1 and 36, the answer will be 5.136. Okay, it is going to be without glass slab, without glass, it's going to be with the glass. Okay, then they are placing chalk powder above the glass slab. Okay, now they are focusing on the chalk powder. Okay, so now they are measuring what is the surface. Okay, already I have the reading for the surface, it's going to be 6.538. I am going to get answer with 6.438. Okay, this minus this surface minus without glass slab, this is going to be real depth. Okay, surface minus with the glass slab is going to be apparent depth. Okay, so real depth by apparent depth is equal to refractive index. Normal subtraction only, you can do subtraction then division, the answer I will get 1.502. Thank you.